All right, cool. Hi, everyone. My name is Moses Sampal. I'm one of the partners at Quantum Computing India. I have Shadab also with me. And Professor Anshul will be taking us through generative AI and using quantum computing for financial analytics. But this will be a very useful session for us in terms of the open projects that we're thinking about. If you have joined our WhatsApp group, you would have already seen in the description a link to the open projects, which is around simulating a Abhishek, I'm going to mute you. Okay? Simulating a particular region's market so that sovereign wealth funds can take a better informed decision in terms of investing in these things, right? So if you look at one of the world's largest sovereign wealth fund, which is Norway's oil fund, or GPFG, these guys, less than 1% of that comes into countries like India or emerging markets, right? And this is $1.3 trillion that we're talking about. Now, the reason being, obviously, it's high risk, right? But high risk from finance term also leads to high rewards. So what is the best way for them to simulate high risk environments like developing nations of India, not just India, also Africa upcoming, right? So can we now use generative AI to simulate these markets and then run algorithms on this digital twin and then move the strategy to the real portfolio? Okay, so this will be the process that we are looking at in terms of the open project. We'll be looking at it in more detail, after the session gets over in the next coming weeks. So this session is very important for that, in understanding how are you going to use generative AI to create a digital twin, and be it for financial analytics, portfolio optimization, whatever the use case could be, right? So with that as a context, I'm going to ask Professor Anshul to take us through.
Yeah. Hi, good evening all. So it's thanks Moses and Shadab for inviting me to take this particular session. So I will just share my PPT with you so that, we can start off with the discussion. I hope now the PPT is visible to everyone. Okay,
yeah,
fine. So as you can see, today we are going to look at digital twins. Basically, what we are looking at, how generative AI and quantum computing, which is the emerging technologies which is coming in the market, they can actually complement each other, right? And if you look at the particular agenda that we are going to follow, basically a little bit of introduction to generative AI, introduction to quantum computing, and afterwards we'll look at what's the need of quantum computing in AI, what is quantum machine learning per se. Then we will look at the generative AI on quantum computers and its BFSI applications that can be powered by both generative AI as well as quantum computers. Now, when we look at it, generative AI per se has gained a lot of attention today. Now, when we try to actually define the generative AI component of the digital twin, we are actually looking at how can we make or produce the realistic data. So, the data can be anything. It can be the time series data, or it can be
jackfruit.
Sorry.
No.
Yes.
Go on. Yeah.
Okay. So how it can be a real image that we are looking at. Also, generative AI is used to produce the generic music based on the text inputs that has been given. Of course, the technology which is powering the generative AI is your GANs, which is your generative adversarial networks, your variational autoencoders, NLP processes that has been there in the process. If you look at it, basically the GAN networks, it plays a cat and mouse game. So what happens is you have one prompt which will try to produce a realistic data, and then the neural network or the let's say the discriminator part which is present over there it will actually try to penalize that particular data, try to find out how much realistic it is based on the defined parameters. Of course, it also includes the component of reinforcement learning and other such neural networks techniques, which is there. Now, just to look at how much realistic generative AI has become, you can look at this picture. So if you look at it in 2014, when we were playing with pixels, the faces which was generated by the generative AI part, it was more grainier in nature, right? If you see, there was no clarity, and when you look at it, it was very hazy in nature. Versus in 2022, when we, sorry, in 2020, when we look at the power of GANs, due to the increased computational powers and the resources which it is consuming, it is giving you a more realistic picture, right? And of course, we have seen different use of it. I mean, we have seen the use of it as well as we have seen how people are abusing it as well. So if you look at it, the deep fakes that we talk about, or for that matter, the tailored videos that we talked about, it also is created by generative AIs, using generative AIs. Now, when we come to the next component, which is, quantum computing. If you look at it, basically, quantum computing, it is based on the quantum mechanics principles, which is defined inside or which is defined by the quantum mechanics in physics. And let me define you the three very important terms that I will be using very often. So one is the qubits. So all of you have heard about the bits part, which is 0 and 1. And using this two digits, we actually process the information or pass the information, right? Now, if you look at it, when we talk about qubits, is the quantum way of processing the information, where we can say, or we can tell that there will be the faster processing of the information, and the thinking power of the quantum computing will be more due to the next two phenomenon which is there. So one is the superposition and entanglement. So when we talk about superposition and entanglement, you should actually evaluate it in terms of contextualized based information and how we are passing on the information. So if you look at it, the memory power will be much more powerful than the current digital computers which is in place to solve very specific type of problem. Now, if you look at it currently, I mean, you might have seen one web series known as Asura 2, which has actually shown you that using quantum computer, you can actually do many weird things. But let me tell you, right now, quantum computing is not in that particular stage. We are still experimenting. So the next question is, what kind of problems that can be solved with quantum computing? So basically, as Moses was actually describing a few minutes back, that if you look at it, quantum computing in particular can solve the simulation and optimization problem, where it can actually give you more realistic view of the underlying matter which is there. So let's say when we talk about the portfolio optimization and in particularly risk analytics, when we try to define the conditions and when we try to define the multiple conditions using current algorithms, let's say Monte Carlo simulation, right? How much accuracy we will be able to achieve, it depends on the parameters that we are defining. Now, you fuse in generative AI in this particular section. So let's say traditional Monte Carlo simulation, and when we have to do the market simulation, actually in a particular day, market goes through some 100 to 120 prompts. So 100 to 120 prompts means it will be influenced by different factors. Let's say suddenly a news related to Indian economy will flash in, then a news related to the Russian-Ukraine war will flash in. Right. If you look at it in real time, if you want to incorporate these kinds of data in the Monte Carlo simulation, there is a limitation, and this limitation is due to the computational parameters that has been defined. But let's say when we talk about generative AI, we talk about chat GPT, very simple. If you look at it, it actually operates on 1.75 billion parameters, right? So chat GPT is, let's say, one example of the text NLP which has been powered by generative AI. So similarly, what happens is with the help of generative AI, you will be able to define more and more parameters. So the more and more parameters that you are able to define to simulate the market conditions, more and more realistic picture you will get for the particular market condition. Now, having said that, if you look at the computational power which is required now, the last article which I've seen, the company OpenAI, which is actually powering the ChatGPT, they have what they have done, which was they are using some 2-3 very advanced supercomputers produced by NVIDIA, which consumes lots of energy to process the information and to process our request. And ChatGPT, mind you, is becoming a very popular application in this particular. Now, what particular properties, especially the qubits, will help you in faster processing of the information, superposition, and entanglement, which gives you the contextual, which gives the contextual background to the information, can help you in processing the information in a much faster way. Right. So now you see that why digital twins, especially generative AI and quantum computing, is they do complement each other. So now, if you look at it, these are the two models that we deploy in quantum computing. So on your left-hand side, you have a quantum annealer, which which is optimization. So D-Wave has started selling this particular quantum computer in 2000s, and now we have seen some real-world application from the D-Wave side. And on the right-hand side, if you look at it, this is a real quantum computer. This is by IBM and a host of other companies, known as superconducting computer. And using this particular technology and quantum mechanics principle, now 7,000 there, and of course Microsoft the catching game, and you can set all these computers using the Microsoft Cloud and the IT Cloud, which is there. Right now, as I've told and as we were discussing earlier also, what is need for the quantum computing or introducing the quantum computing in AI? As I've told you, these are the two challenges which we face in classical computing in solving the particular class of problems known as the NP-hard problem. So let me define the NP-hard problems for you. So right now is, so as you can see, my screen is visible to all, right?
Not yet, not yet.
Not yet?
Yeah.
Just a second.
Yes.
Okay.
Right. Now we can.
So now is it visible?
Yes.
Okay. So when we talk about quantum computing and when we talk about classical computing, so classical computing basically we can see that challenges that we are facing is the computation time and the energy efficiency. So let me define what is the computation time. And we were talking about the NP-hard problem and the class of problems that can be solved by the quantum computer. So as I have told you earlier, that quantum computer in particular is a specialist in solving the optimization and the optimization as well as your um, simulation problems, right? Now, if you look at it, the digital resources or the computing resources to run the optimization problem for, let's say, a portfolio optimization, it consumes a lot of computational times. It's a very lengthy process, and that's where the quantum computing is gaining, or theoretically, once it is able to resolve the issues associated with it, is gaining the market, right? And when we talk about the energy efficiency, as I have told, the OpenAI ChatGPT servers, they are actually consuming a lot of energy. So it's not very green in nature. And what is the potential of quantum computing? Quantum computing is, it can handle complex problem with good speed, right? So let me give you a very simple analogy over here. Whenever you are using ChatGPT these days, of course, I'm assuming that everyone of you is familiar with ChatGPT. Uh, what we see over there, or generally what we see is that you know it gives you the answer, but that's not accurate in some of the context or in most of the contexts that we see, right? So in particular, when we look at it, um, let's say there will be some information which will be missing, or some contextual information which our human brain has processed, but it will not be there put up by the ChatGPT. But this particular gap can be overcome by the quantum computers, or in theory, it can be overcome by the quantum computers using its computing power. Now, when we look at the next, what is quantum machine learning, and what are those particular algorithms that we are looking at? So, just let me take a pause in between, and I want to ask all of you: have you actually come across quantum machine learning or this particular term before, or have you worked? Have you looked at it by any chance? You can unmute. Shadab, can they unmute and then tell?
Sure. I think Kishan has said yes.
Okay. So if you can just tell me, what you have understood by quantum machine learning.
Yeah. So based on my understanding, Anshul sir, I mean, it is not very much like classical machine learning, but quantum algorithms and the power of quantum computers are being used to run those mathematical computation to come to a formula, right? So through that, the machine can learn and predict something or forecast something.
Okay. So basically, let me tell you what is quantum machine learning. So, you might have heard about very popular machine learning algorithms like support vector machines
Yeah,
and,
QSV.
neural networks, or for that matter, linear regressions, right? So what we are looking at right now is that can we include the quantum component in it? So when I talk about quantum component, can we bring in properties like entanglement? Can we bring in the properties like qubits? And similarly, by bringing in these particular properties, can we enhance their performance? So let's say if they're 95% accuracy, or when we talk about fraud detection cases, uh, uh, when we are able to define, or when we are able to get 96% accuracy, how we can actually make it more real, more closer. of course, let me tell you with the conviction and with the confidence with speaking, quantum machine learning is in very nascent stage as a field. It has not reached up to that particular stage. It has not reached that particular stage actually, right? Okay. Now, when we look at it, basically, quantum computers, they are used as an optimizing. They are used as optimizers in terms of generative AI, and they can actually give you, or they can give you better optimized machine learning or better optimized results when it comes to the machine learning algorithm. So just if we want to recall what we have discussed till now, we have started with the definition of generative AI, and we have started with the definition of quantum computing. We have looked at what are the 2-3 properties of quantum computing which make it so useful for the generative AI. And then, we have looked at what are the different types of quantum computers are there, like quantum annealers and quantum computers, which is there. And afterwards, we are looking at currently at what is quantum machine learning, what is the benefits of quantum machine learning, and how quantum computers can optimize the machine learning algorithms. Now, having said and introduced you to all these components on the theoretical aspects that we are going to discuss now, let me show you to the next event. So this is the thing. So as you can see, or as you can observe on your screen, this is of course a generative AI prompt of the Satyagraha, which has been generated. It's a pencil sketch. Now, how I can make it more refined and how I can make it more realistic can actually quantum computer visualize Mahatma Gandhi over there leading the Satyagraha. So this is the question that is there. So, how I can make it more real, right? Okay. Now, when we talk about, generative AI and what is the marriage of generative AI and quantum computing will do. So, as as we were discussing earlier, a potential tie-ups or potential complements of generative AI and quantum computing, it helps generative AI on 2 parameters. And these 2 parameters I have already defined earlier. These 2 parameters are computation time and energy efficiency. So as you can see over here, basically it can solve your problem more faster. It can solve your problems in a more accurate way. Now, having said that, there is always, room for improvement, and QML, quantum machine learning algorithms, and quantum computers with quantum simulators and real-time quantum computers, they have the potential to speed up the training process of the generative models. Like if you see right now, ChatGPT, if it is training on 1.73 billion parameters, right, it is actually consuming a lot of computational resources. Can I bring it down to, let's say, from billion to million? Can I define it as, so instead of having 1.73 billion parameters, can I get the same results after going through 1.73 million parameters, right? Which can be more realistic and which has actually, which will actually reduce our cost as well, right? Now, so this was the first half of the presentation that we were looking at. Now, when we move towards the next half of the presentation, first, let's have a look at one of the very famous FinGPT framework. Of course, it's not developed by me. I will give you the reference afterwards. It's developed by 3 Stanford students. And what we were looking at, or what we are looking at an architecture which is hosted on cloud like IBM, Azure, or AWS, and has been divided into 4 layers. So as you can see over here, the 4 layers that we are talking about, first layer is of the data source. Of course, it's in looking at 5 types of data sets in particular, which is your news. So as I was telling you, right, in the context of the stock markets, small news can actually swing the trades, right? And major news can swing the trade in a very, very major way, and in a very I mean, it can actually bring down the stock market by a few thousand points, or it can actually raise the stock markets by a few thousand points, right? And with the near accuracy, can we actually predict these kinds of phenomena, right? So news, then the social media is a very big influencer these days, especially the Reddit and the Twitter part. People, they do discuss about the news which is not there in the main media. And the filings of the companies on different stock exchanges like SEC and NYSE and NASDAQ, and what are the current trends related to stock markets, which is there. So it's Google Trends, and we seek alpha, which is related to this. Of course, then there are regular stock market data sets, which is there, which talks about your stock prices closing, and it can be a 1 minute stock price, or it can be a hourly stock price, or it can be a daily stock price, right? Now, having said that, having looked at this particular data source, we go towards the next layer, which is your data engineering. Just give me a minute. Which is your data engineering. Of course, it's a process in itself, and we are talking about the NLP process, which starts with data collection and streaming of the data, and then the data cleaning, which involves a lot of stemming and then tokenization and the lemma of the data. So basically, we'll try to get the context, and we'll try to get the sentiments out of that particular data. Feature extraction is something which I would like to talk about. So using NLP, we can actually look at different types of signals, trade stock market signals that has been produced by the data sources which we are analyzing, right? And based on this, we have to do a lot of prompt engineering, and current LLMs that we are looking at. So these are the direct to use OpenAI's, which is there. So you can have a look at ChatGPT, Moz, Palm, GPT 4.0, and we train this model. So there are underlying architectures like GANs and VAE, which powers these kinds of generative AI models. We fine-tune the models using the tensor networks and using the reinforcement learning models. And then we drive out various kinds of applications. So various kinds of applications that we are looking at is your robo-advisor, quantitative trading. We are looking at ECGs, ESG scoring. We are looking at financial education, credit scoring, right? So these are the host of applications that we can look at. Now, why I've used this particular framework, this is a typical generative AI or ChatGPT type of, let's say, network that we are looking at. Now, having said that, or having looked at this particular thing, what we can see that quantum computing or quantum machine learning algorithms can be used in 2 parts. One is your data engineering, and another one is your LLM part, right? So in the next few slides, we are going to have a look at it. Right? When we look at the BFSI applications, So these are the data sources, different data sources, of course, that I have talked about. Okay, so these are the data sources that will work. So if you look at, we an input, so input can be a prompt in terms of text, or it can be a data file in terms of stock markets, or it can be a combination of both. And how does it work over here? It's very simple. So if you look at it, two major layers that we are looking at, the generator and discriminator layer over here. When we and basic objective is to produce different kinds of data. These are the different data sources.
Right. Yeah.
So these are the basic data sources that we are looking at, right? So this I have described in, while describing the FinGPT architecture, described in details that what are the different types of data sources we can look at by preparing the financial applications, especially related to the stock markets, right?
Right. And most of these have open APIs?
Yes. So if you look at it, SEC has open API, and few of the data sets that they have open API. Of course, Twitter, Weibo, Reddit, they have very limited APIs, which is there.
Right.
But you have other ways to extract the data from there. Now, having said that, the news one, Yahoo Finance is open API, but Bloomberg and SEMA and Wall Street, these are the paid ones actually that we are looking at.
All right.
Right. So the next architecture that we are looking at right now is the basic GAN architecture. So how does it work? So, you have to use your imagination a little bit. So, we are giving in random input. We have tried to now we have given the news headlines as an input towards this particular GAN model, right? So what does the generator do? Basically, generator will read all those newspaper headlines. Okay, it will try to assess what is the underlying or the hidden pattern which is there. It will try to mimic that particular data, and it will try to create a realistic data, right? Or let's say, when we talk about the image creation, it will rearrange the pixels in such a way the picture which you have originally given, it will try to make a similar kind of picture, right? It uses basically it uses different kinds of learning process. It takes a feedback from the discrimination from the discriminator. Discriminator, what is the real objective? The discriminator objective is to differentiate between the real data and the data which is generated by the generator part of it. Okay, and it acts as a critic that evaluates if the generated data is real or it is fake. Now, it's a very, very important input that we are looking at. Why? Because, with the help of the discriminator, generator will eventually make your data more and more realistic in nature, right? Now, I hope all of you have understood, how does GAN works, and then using this particular GAN, as you can see, this is the typical quantum computing model that we are looking at. So what we are looking at right now, using a similar input, we will have a classical pre-trained model. Now this classical pre-trained model, what we are looking at will be powered by the quantum circuit. It will be powered by the quantum machine learning algorithms, which I will show you very shortly. And it will give you the output. Okay, so basically, if you look at it, quantum machine algorithms, where it has got the advantage, it has got the advantage in terms of optimization and in terms of simulation, that it gives you more realistic results per se, right? Now, having said that, how we can actually make it more realistic? This is the learning method. So if you look at it right now, GANs, which is based on the tensor layers. They are using, so it's the current architecture which is used in FinGPT. It can be potentially replaced by a variational or a feature encoding features from the quantum computers. Right? I'm not going into the too much of the technical details, but what I'm trying to show is that these are the let's say proposed replacements that is there, which will actually make generative AI more powerful, more economical, and more realistic, right? And so this is the things. These are the things. So basically, when we look at it, when we look at one of the reinforcement learning model is that you have various types of observations in the prompt engineering. The actor, which is your LLMs, they they will give you the recommendations, which based on those recommendations, you can actually buy, sell, or hold the your stock transactions. And then based on that, you can have a simulated transactions, and you can have a look at what kind of returns that you are looking at. And the entire game that we are playing is in the second square, which is the LLMs part. Right. These are the various algorithms which have which has the which can potentially replace your current GANs and variational encoders (VE). So we are looking at variational quantum icon solvers. We are looking at QAOA, which is a very popular algorithm these days, and it gives you a lot of it helps you in handling a lot of optimization problems. We can also look at quantum support vector machines, you know, to clean the data. And of course, we have the HHL, which is Harrow and Light algorithm. It actually gives you, based on the linear systems, it gives you or defines the plane and gives you the more realistic results, right? So these are the set of algorithms which will give you or which will help you in achieving the potential results or potentially better results, which is there. This is like one of the application that I can thought of. This is your robo advisor, where based on the news articles, and you can actually look at what are the possible trends. What is the overall outlook for the Apple company? If it's positive, so it means we can expect Apple prices to go high. And if there are a few negative articles, how much it is going to impact the stock prices. Right. This is one of the trading signals that we are looking at. And when we are looking at the DL and RL model, which is your deep learning and reinforcement learning model, it will be replaced by the quantum machine learning model, so which is there. Of course, every other application will remain same. So you will have your trading signals, you will have your portfolio allocations, which is there, sentiment factors, and the price factors, which is coming into the pictures. Now, these are the different parameters of differentiation where quantum computing or quantum computers can actually replace the classical computers. One is the computational efficiency. It can actually, so it has been proven that QML algorithms can actually train on small section or the small amount of data and can give you the equally accurate results. You don't need large data sets, right? Then there is a issue of noise and error tolerance. As I've told, quantum computers are in very nascent stage. It is error prone. It might not give you the desired results. And of course, there is a complexity in implementation. There are very few quantum computers. This particular key of technology is held by a few countries only, like US, China, and Finland. India is yet to come up with its first quantum computer. They have started making it in different government facilities like ICER and CDEC, but we are actually a decade away from getting our first quantum computer, which is there. And then the interpretability and the regulatory compliance is also there. Current frameworks which is available right now is less for the quantum machine learning, and work is going on to make it more interpretable. Of course, when you look at the classical computing and when you look at the Python libraries that is available on reinforcement learning is much more in number than the popular Python Qiskit libraries is there, and other Circu libraries which is there. But it holds a lot of future potential, and I'm pretty confident and optimistic that in next 10 years we will be actually seeing a lot of real-time applications of the quantum computers powering the generative AI. So I'm done with my lecture over here, and actually open for the question answers session. So we have looked at what is the potential of combining the generative AI with the quantum computing. Moses?
Yeah, lovely. Thanks a lot. The last few minutes were really new. Guys, any questions, you can put it in the chat. I'll read it out if you're not comfortable.
So basically, I have to bring in both the perspective, the developer's perspective as well as the practitioner's perspective.
Right.
So that's why. So that's where it might have got a bit technical in the end, but people need to look at that what are the potential algorithms, so that if anyone is interested in developing those algorithms, taking it forward, they can do that actually.
Can you go back like I think 4 slides where from classical to quantum encoder thing was there? Yeah. Before, just one before. Yeah. Okay. So how much of this will go into the quantum circuit? Again, in terms of computations. Okay. So right now, as you have been mentioning from the beginning as well, if we don't have enough qubits to kind of simulate or run most of the algorithms, the current way the industry is progressing is a hybrid model, right? So you use high performance computing to do most of your classical computations.
Yes.
And the very important ones that you moved into a quantum computer, right?
Yes.
So what do you think is the percentage here?
So if you look at it currently, I would say it's a 0%, because
okay.
If you look at it, they are just exploring it. There are use cases, and those are also not a very successful use cases. So, to be very realistic, Goldman Sachs have given up on quantum computers few months back. But having said that, JP Morgan is investing very heavily on this particular stack of tech.
Yeah.
And other. So I'm talking about finance. There are companies like Multiverse, and there are banks based out of Spain. Currently, like I'm working with one of them who are exploring these particular use cases. So, you can think of it like this. They are trying to develop a secret weapon, which is in a very experimental stage.
Right. Okay. Do you think there's a possibility for us as a community to work on, let's say, a Fin model, Fin GPT, like this?
Definitely. So I will share the link with you afterwards.
Okay.
It's an open source model which is developed by 3 Stanford students. They have made all the codes open actually.
Okay.
So you just have to adapt those codes based on the applications that you are trying to develop.
Right. Okay. Cool.
So that particular thing, can be commercialized on immediate basis, because you have all these APIs which is available.
Right.
Like if you just give me 1 minute, I will show you one example.
Sure. Yeah.
Give me 1 second. Okay, so right. So as you can see, I have opened something known as finchat.io. Okay. So this is the AI chatbot for investors. So let me ask this particular question. So they are giving you the demo over here. Summarize Microsoft last quarter with a focus on cloud business. Include transcripts from CEO Satya Nadella. Now, if you look at it, basically the data layers that it is using from my PPT, if you compare it to my PPT over here, it is actually using your event data set, and it is using your SEC filing data set, which is there. Right. And it is giving you all the tips and techniques, and it's a paid subscription which is there. So, based on ChatGPT, they have actually contextualized it and made it very, very commercial in nature.
Also, Anshul, sir, there are fintech-based LLMs as well, right? Like
yes, there are fintech-based LLMs as well. Right.
Okay, and in terms of quantum generative AI, it's still too much of theoretical, or any basic implementation is also done?
Basic implementation, of course, has started happening in QNLP and QGANs. That is the new set of algorithms which has come into the picture. But still, it is very, very nascent in nature. I mean, I would not place any bet on it as of now.
Okay.
So that is there. Anything else? Any other question that you have, or shall we conclude the session now?
Yeah, I don't have any questions, but I saw something on the chat and then it went away. Madhuri, was that you? Like,
okay. So what we are looking at,
it is me. I got little confused. Like it is a pre-trained trained model. I confused with the pre-trained data. So
correct.
I got clear. That's
all right. Cool.
Jayant is asking one question: is how to build chips that support quantum computing. And see, now everyone has started playing their games. Until recently, they have unveiled their first semiconductor-based quantum computing chip. We are yet to analyze and yet to see it in action. Only thing which is closer right now to anything commercial is IBM, and they themselves are telling that we will take today is 2023. We can have they will take in the next 5 to 10 years. So you can see first commercial application in 2035 actually. Okay, Kamalpreet is asking in BFSI application slide, what could be the scenario of sentiment factor? Okay. I'm hoping you are talking about this particular slide. So if you look at it, we are looking at, 3 text-based data sources over here. One is news, social media, and filing. So what happens is these result into the emotional response from the investors. See, basically, if you look at it, particularly right now, stock market is the game played by the big mutual funds or hedge funds, right? They pour in million and million of dollars, and they do something known as quantitative trading, and they do something known as flash trade. They will reverse the entire thing in 1 or 2 microseconds, and then the daily investors will catch up or playing the catching up game of the let's say, okay, market is going up, market is going down. Now, if you can gain 1 or 2 seconds of advantage on that, and to generate that 1 or 2 seconds of advantage, we actually go through this particular sentiment analysis or sentiment patterns that is there. So, it is useful to generate that kind of signals actually. So I hope it answers your question that, what is the role of the sentiment analysis in the trading.
So, Anshul, so for sentiment analysis, I think one company from UK was working on that at QNLP package and all they have delivered QT
Yes,
type.
yes.
So, I mean, in comparison to the classical part, like when we do sentiment analysis using any of the deep learning algorithm and with comparison to the quantum part of it, like, have you seen any advantage like in
See,
time?
theoretically, they have shown a lot of advantage, but commercially, they are yet to, show any particular advantage over the reinforcement or the DL algorithms. Actually.
Okay. Okay. So, I mean, LLMs can also be like utilized for understanding the sentiment from any of the tweets or news trends, right? Because they have a lot of.
LLMs can definitely do LLMs. So basically, not the LLMs or large language models, the technique, generative AI can, do it in a very faster way. And the type of traders which works on these sentiments are known as discretionary traders.
Okay. Got it.
Okay. So thank you very much. I think I will just take the last question, which is, can it be live videos and can it do live video sentiment analysis? Yes, it can do all live video sentiment analysis. In fact, if you look at it, so you look at it like this. There are LLMs which gives you the YouTube video. YouTube video scripts, right? You feed those scripts into any of these NLP models, and it will give you the sentiment analysis. And it can be an pipeline, a feature pipeline that can be done. Okay, Naveen is asking, how can we use generative AI and quantum computing in calculating the credit score? Okay, fine. See, you look at it like this. Apart from having, so we have all these credit scores from CIBILs and other areas of the world. Having said that, companies do a lot of scrutiny of your social media and of your professional media circuits as well. So they might go to your LinkedIn profile. They will see what kind of post and what are kind of companies that you are associated with, and it can be taken as a positive sentiment or as a negative sentiment in your in this particular manner or in that particular context. So that's how it helps towards in calculating the credit score.
All right. So just to add to the last two things. So one, I think, data at the end of the day, from a computational standpoint, it's zeros and ones. So whether it's text or images or moving images, given the fact that we have GPUs and even like QPUs in the future, live video analysis is not going to be an issue. What you exactly extract out of that, for example, like today when the session was, before I was preparing for the session, there's one Zoom tool. I didn't actually use it because I got a little paranoid. It's called, there's a Zoom app. Okay. So what it does is, if all of us have our videos on, right? So it essentially like live, real time, it's showing what's the engagement score. Okay, it's insane. I was just testing it on myself. And when I was smiling and I'm talking, then my engagement score goes up. It's real time and it's just happening on Zoom. Okay. Which means it's not happening, I don't know how much of edge computing is happening over here. So it's processing power at my computer's level. And it's like sending it to Zoom's close by cloud server. It's doing some analysis, sending it back to the score. It's that live, and it's happening right now, right? And it's on Zoom. Okay. So what, I mean, it's a no-brainer, right? So any kind of data, if you're able to take sentiments out of it, for example, the current France uprising that's happening, would we have spotted that like a week ago that this would happen, right? Or at the particular moment when this black Muslim guy was shot, would we have foreseen that, okay, next 4 weeks, there's going to be riots in France? Then you could have like played around. If you're trading, then you'd have shorted, yada, 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 right? So it really depends on, it's not the question of whether we can do it, but how good the algorithm is in terms of predicting so that we can use that for our own advantage, right? So that's that with respect to real-time thing. Generative AI and quantum computing and calculating credit score. Yeah, like Anshul was saying, there's one paper. So this post is written by me. So it's part of my book. It's called The Internet of Value, where we talk about how we are moving away from credit score to reputation score to well-being score. So once our white paper is released, you guys will understand more about well-being score. But this post should give you a high-level understanding of ideally why we should be doing that and who should be owning that data. Okay. But so in this post, I must have mentioned about this one paper that I read, which is how all data is credit data. That's what Anshul was also saying, right? So it's not just your transaction data in terms of, how quickly you pay your credit card bills, your postpaid bills, all these transactions are now anyways being either within Cred or Google Pay or one of these UPI-enabled apps. So transaction data is not the issue. And given the fact that now your Aadhaar will be linked with your PAN, and so financial data is the high level of all these things, right? So credit scoring agencies have gone deeper. So they will essentially now go and look at your social media posts. They'll see, whether you're pro-government, anti-government, right? So these kind of things. So anything that you post on social media is essentially it's already happening, and it's going into your credit score. It's affecting your credit score right now, right? How much, what's the weightage of that? All those things we wouldn't know because those algorithms are opaque. And that's one of the reasons why we say, hey, well-being score has to be transparent. It's an open protocol. And then like the community can essentially decide what's the one parameters that goes into that, to the weightage of the parameters that goes into measuring the well-being score, right? So if you guys are interested, go read that. Yeah, so I think those two things I just wanted to add to the last two questions. With respect to, okay, thanks. I mean, Anshul, you want to add anything?
No, I think you have handled it quite well, Moses.
All right, thank you. Okay, so let me just like one call to action to people who are here. So as a community, Quantum Computing India, we are in this phase of restarting this in terms of more equitable for everyone who's involved, for the time that they're putting in, even this time that you guys have put in terms of either attending the session or giving the sessions, all this will be equitably compensated, right? So that's what our white paper will cover in terms of converting QCI from a community into a decentralized autonomous organization, but not from the typical crypto bro perspective, but more in terms of really rethinking value. So that's where the Internet of Value, which is the open protocol stack that we have come up with, and Quantum Computing India is a community that's part of the Internet of Value that we are building, right? And if you're not part of the Quantum Finance WhatsApp group, do join there, because that's the first line of communication between us. And as you have seen, like on our site, we have a open project. Let me just put it up over here. So we are working on this particular open project. It sounds massive, but it's doable. So 2 years ago, we had run hackathons around this. Again, if you look at our Quantum Finance WhatsApp group's description, I put all the YouTube videos. We have like, till now it was unlisted, like, but now I've made all those things public, so you guys can go through that. So that we were doing it in 2020, right? Like back then, generative AI wasn't this prevalent. Like we didn't have access to ChatGPT, all those things. So we were limited. And even then, Shada was also part of the project, right? So we are restarting the project, but this time we are going a little further and we are really targeting only sovereign wealth funds. And if you're like listen keenly to Anshul's talk, the real market movers are like how much of money you have. That's the advantage that you have in the trading market, right? So the biggest movers are right now sovereign wealth funds. And sovereign wealth funds, the top sovereign wealth fund like Temasek of Singapore or Oil Fund of Norway and UAE related sovereign wealth funds are the ones that we'll be targeting. And given the fact that we have extremely smart people within the community and advisors like Anshul who had agreed to be part of the project in the near future. So that'll be our actual actionable thing that we'll be working on as a community, right? The events will still continue. The learning circles will still continue. The fellowships will still continue. But the question, if you had inside you, which is, hey, man, I'm just like stacking up all these certificates. What's the point of this, right? If you have been in that, and if you have like asked that question to yourself in the last 2-3 years in terms of quantum, we never know when is that watershed moment, right? Like when is this ChatGPT kind of moment that's going to happen? All we can do is be prepared. And then we'll be called as lucky people, right? Because we were prepared and we were putting in the effort. So I sincerely urge you to like kind of go through this page and apply. And again, based on our experience, so we really want to make sure that the right set of people come into this project. So the first way for you to get into this project is to join the community. And joining the community is not easy now. It's not open. It's a quest. So it's a 5-stage quest that you have to complete. 2 people have already completed, like though we haven't promoted anywhere. This is the first time I'm probably saying it to people, though you're within a private space right now. So you can go through that. The last question will be a little tricky because the white paper is not public yet, right? But still, if you're smart enough, you'll figure out the way, right? So that's the first step. So you join the quest, you finish the quest. The second thing is on this particular page, we have a drive folder that essentially has a bunch of readings. Go through that and then apply, right? And then we'll have an interview and then you'll be part of this open project, okay? So that's the info/call to action from our side. But apart from that, in terms of announcements with respect to how we are looking at this entire year progressing for Quantum Computing India. So July 29th, we will be having an offline launch, a relaunch of the community in Bangalore. So if you're here, more than welcome. And then, Shadab, correct me if I'm wrong. So by August 15th, we'll be starting a hackathon, and that will end in October, right? So till October, that's the plan that we have. Shadab, yeah. Want to talk about it quickly? Muted.
Sorry, I was on mute. Yeah, regarding the hackathon, I will just add up. So this hackathon, we are trying to onboard for many use cases in quantum industry and not just focusing on a particular area. So if you have any idea related to any of the domain or industry, like quantum finance, defense, automotive, anything like whatever you can think of, you can start ideating from right away instead of waiting for the launch event, basically. And after the launch event of the QCI, like as Sam has highlighted, we will be doing the launch event for the hackathon, and you will see many companies partnering with us, and there will be a lot of like goodies and prizes and mentoring sessions as well with whom you can connect and learn on the go. Yeah.
Lovely. Okay, so just to summarize, thank you, Anshul, for this nice session. Really informative. It's going to help us with the projects as well. And people join the community, finish the quest, apply for the open project. If you're in Bangalore, join the offline event and sign up for the hackathon. And as always, we'll be putting up all these things in our social media /WhatsApp group. So information reaching you is not going to be an issue. Really, you filtering it, making sure that it's going to be useful for you and joining that and seeing it through. That's where the real talent is right now, right? It's not the lack of information. Okay. All right. Thank you, guys. Thanks a lot for joining. I know it's a long weekend. Thanks for showing up. Ciao. Take care.
Thanks, guys.